Worksheet 4.1, question 5. We have W, X, Y and Z are 4 points in order on a straight road that runs up an incline and makes a constant angle of 12 degrees with the horizontal. So we're going to draw our horizontal. Here's our incline of 12 degrees. And we have our points W, X, Y and Z. So we've got a viewing tower of height H stands at W. So here is our height H. Here. From X to Y, the top of the viewing tower has elevations of 32 degrees and 18 degrees above the horizontal. So the first thing we'll do is mark in our horizontal at X and at Y. So there's our horizontal, and here at X we've got 32 degrees and at Y 18 degrees. So here at X, because this is 12 degrees here and horizontal on the ground is equal to horizontal here, or parallel with horizontal here for our X, so here is 12 degrees. So together this will make 44 degrees. Here again, horizontal is parallel to horizontal, so here will be 12 degrees. So this total angle here will be 30 degrees here. So now we're told here if XY is 100 meters long. So here this length here, XY is 100 meters here. We want to know what is the height H of the viewing tower. So just to make things a bit simpler, we're going to label this point here K, just so we can label our triangles nicely. So here, when we look at this, if we look at triangle WXK, our H is on there and we have one angle, but we need to get more angles or more lengths there, so that doesn't help us a lot. If we look here, we can get this angle here, so we know the height H with the horizontal makes 90 degrees, and we have 12 degrees there. So this angle here will be 90 degrees minus 12 degrees is equal to 78 degrees. So it's still, we need a bit more information about this. We have two angles but no sides. So here if we look at our large triangle here, KWY, we know two angles and we don't know lengths. We know part of this length between X and Y, and that's our first sort of clue here. We know this length XY. So XY is 100 meters, and we draw this back to our point K here. We know that this is 30 degrees. And our angle X, so here we have a straight line. A straight line is 180 degrees. So any angle on a straight line add to 180 degrees. So this angle on this side here will be 180 degrees minus 44 degrees here. So this one is 126 degrees. So here we know two angles. So with a triangle, if we know two angles, we know three angles because they add to 180 degrees. So here our angle will be 180 minus 126 minus 30 degrees here. So here our angle will be 58 degrees. Sorry, it will be 24 degrees. So here's 24 degrees. So we have three angles and one side here. So we can use our sine rule. So with these sides here, if we find this side here that I'm labeling X, this X here, this will give us a length on our triangle WXK that we can use to try and calculate our height H. So we're going to find our side length here X. And so using our sine rule, we're going to have X divided by its opposite angle here, sine of 30 degrees, is equal to 100, the length that we know, divided by sine of 24 degrees. Rearranging, we get X is equal to 100 sine 30 degrees divided by sine 24 degrees here, and our length X will be 122.93 meters here. So here 122.93, and we can write it here 122.93 meters. So now if we look here at our triangle KWX, so we knew already 44 degrees here. We knew already 78 degrees here, and we can work out this angle here if we need to, is 180 minus 78 minus 44 is 58 degrees here. And we know this is our length x, so this is 122.93 meters. So now we know 3 angles and 1 side, so we can use our sine rule again. So we're going to say here our h. So h divided by its opposite is sine 44 degrees is equal to 122.93 meters that we know divided by sine of 78 degrees. Rearranging, h is equal to 122.93 multiplied by sine 44 degrees divided by sine of 78 degrees. Here, into our calculator, and we're going to find that h is 87.3 meters here. So we've found here our h is equal to 87.3 meters here. So for our part B, or part 2, we know, okay, they're telling us YZ is also 100 meters long here. And we want to know what is the elevation of the top of the viewing tower from our point Z here. So we're wanting to know this angle theta here. So what we're going to find here, and our angle of elevation will actually be this part in here, so it'll be theta minus 12 degrees once we find that here. If we look at what we know on this triangle, this part here is 30 degrees, so this angle here is 180 minus 30 is 150 degrees. So now it's going to be helpful if we can find this length y here. So we know our details from here, our XYK triangle, and we can find our y on this triangle here. So we'll put it up here. So we'll put this part up here. So here we're going to say, well, y over sine of 126 degrees here is equal to 100 divided by sine of 24 degrees. So y is equal to 100 sine 126 degrees divided by sine 24 degrees here. We enter that into our calculator here, and it's going to be 198.9 meters. So 198.9 meters. So now we know 2 lengths and 1 angle here. So we can use our cosine rule here. So if we draw it, we can use here, we're using the red. So here for our triangle KZY, we're going to use the cosine rule. So we're going to say a squared equals b squared plus c squared minus 2bc cosine of a. So our angle here that we have here, this is our a. So our lowercase a goes here, and our b and our c here. So our a squared is equal to 100 squared plus 198.9 squared minus 2 times 100 times 198.9 times cosine of 150 degrees here. So we end up with a squared is equal to 84011, and a will be 289.8 meters. 289.8 meters here. So now I have 3 lengths and 1 angle. So now 3 lengths and 1 angle, so we can use our sine rule again to find our theta here. So we're going to say here our theta relies on this here, so it's going to be 198.9 divided by sine of theta is equal to 289.8 divided by sine of 150 degrees. We cross multiply, our sine theta comes over here. We're going to end up with sine of theta is equal to, here cross it across, So here, we'll go through the whole process here. So run out of room, but we're going to have 198.9 multiplied by sine 150 is equal to 289.8 sine theta. Here, and we multiply this out and divide here, so we're going to have sine of theta is equal to 198.9 sine 150 divided by here 289.8 here. So we enter this into our calculator here, and we'll get 198.9 sine of 150 degrees divided by 289.8 here. So here sine theta here will be 221 on 644. Here shift sign of the answer. So our sine theta, or our theta will be 20 degrees 4 minutes. And we know that's our whole angle here, theta. So here, our angle that we're trying to find, our alpha, will be theta minus 12 degrees. Here, that's the 12. So minus the 12 degrees here. So our angle alpha here will be 8 degrees 4 minutes here. So here it would be 8 degrees and 4 minutes there.